This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will provide the solutions for exercise 7, questions 3 and 4, which focused on decision making using the if and else statement. Question 3 is about writing a function to evaluate a function involving x and y. The function containing x and y is different depending on whether x and y are greater or less than 0. So we will use the if-else-if statement to handle these different cases. I have created a new N file and as usual included the function definition with some comments. If you look at the function definition, you can see that the output is a variable called result. The function name is function underscore xy, and the input variables are x and y. So our first condition is if x is greater than or equal to 0, and if y is greater than or equal to 0, the function should return the result x plus y. Therefore, the if statement is if x is greater than or equal to 0, and here we use the and sign, ampersand, and type y greater than or equal to 0, the result will simply be x plus y. Now we use the else if condition and add if x is greater than or equal to 0 and y is less than 0, then the result is x plus y squared. Again, using another if-else statement, we add if x is less than 0 and y is less than or equal to 0, the result should be x squared plus y. Finally, for the last case, we don't need to check x and y, because if it is none of the above cases, it must be the last one. If this last case is true, then the result will be x squared plus y squared. Lastly, we close with an end and save the function. Now you can test your function and try it with different x and y values to ensure that the result is what you would expect. The last question in exercise 7 is question 4. Question 4 is about writing a function to calculate the force of fluid flow in a pipe. You are told that there are 5 different input arguments to this function: the pipe diameter, the pipe length, fluid volumetric flow rate, density, and fluid viscosity. The first thing we do is input our function definition line and variable dictionary onto a new blank script file. So we've defined our output and the various inputs for the function, but we will also need some local variables to store things like the average fluid viscosity, cross-sectional area of the pipe, Reynolds number, and the friction factor. so we will now define them in our variable dictionary. Remember, when we talk about local variables, we mean that those variables only exist within the function itself. So you will notice that when we run this function, those variables don't appear in the workspace, so they can't be accessed from any other functions and scripts within MATLAB. Before we calculate the energy loss, we first of all have to calculate the cross-sectional area, the average fluid velocity, and the Reynolds number. The area is simply pi d squared over 4. The average velocity is the volumetric flow rate divided by the area. So, once we have determined these quantities, we now have to calculate the friction factor in order to find the energy loss. The friction factor varies depending on the value of the Reynolds number. We therefore have to use an if statement for both laminar and turbulent flow cases. The first case is if the Reynolds number is less than or equal to 2000, then the friction factor F is simply 64 divided by the value of the Reynolds number. If this is not the case, we need to calculate the friction factor based on an expression based on the natural logarithm. That ends our if statement and now means we can calculate the energy loss. Once saved, we can test the function with the values you were given in the question. You can define the values and assign them to different variables in the workspace before running your function, or, as we will do here, simply input the numerical values directly into the command window. As you can see, it returns the answer we expected.
This production is copyright The University of Edinburgh.